So with the fifth video of the embryology, we'll be looking at another conventional sort of a question that you see in most examinations. It is about the differentiation of the oocyte that you see. There are multiple stages of meiosis, and you tend to see them arrested at different processes at different times and different locations. So this is about that scenario. So if you look back, this is in fact a little bit of physiology. So at birth, now what usually happens is that initially there are germ cells, primordial cells. They differentiate to form primary oocytes. Primary oocytes are the ones that are found at birth. They are arrested in uh, sorry, prophase 1, and then at puberty they are stimulated by the hormones FSH and LH and starts ovulation. At ovulation, the primary oocytes form secondary oocytes by completing meiosis 1 and proceeding to the meiosis 2 phase. Secondary oocyte again, but at ovulation it is arrested at metaphase 2. Then at the time of fertilization, just before fertilization, with the penetration of the sperm head and the entry of the haploid nucleus of the sperm causes a chemical cascade which would lead to the completion of meiosis 2 and formation of the polar bodies. So at initially at ovulation there is one polar body, and at fertilization it gives the other polar body, the secondary polar body. This further divides into two secondary polar bodies. The formation of the secondary polar body is something clinically trivial. It doesn't have any functions, but the importance is that this causes non-uniform, sort of a irregular division of the cytoplasm, allowing most of this nutrition at the cytoplasm and the organelles to be given to a single cell rather than being split upon four. So only one will develop to form the actual ova, while the other three will degenerate. And later with time, the secondary polar bodies will be reabsorbed. So now, looking at the numbers, usually the number of primary oocytes will increase to around 7 million at the fetal age of 6 months or so, and will reduce up to 1 million, 1 to 2 million, around 2 million at birth. So this is at birth. Then the number of primary oocytes will gradually reduce up to around 40,000 until the age of puberty. Then from puberty onwards, the number of cells, there will be cyclical development of follicles, and the number will descend. Usually around 400 ova will be released during the lifetime until menopause, and at menopause usually it resides around 100 or less number. Still it's not zero, there are certain clinical evidences where you see sometimes uh, ovulation from happening and having kids, but however it's not very common and something very rare. So at menopause it is around less than 100 primary oocytes that are available. That's why because of the less reduced number is it has been assumed that it might play a role in the age at which the ladies attain the menopause. So looking back at the question, at which stage is the primary oocyte arrested at time of, it is arrested at prophase 1 of meiosis. So A would be the answer. This is a single best question. This is the fifth question that we have discussed regarding embryology. We will be coming with the sixth